In this video, we're going to be looking at Descartes' Rule of Signs and see how it can help us figure out how many positive real zeros and how many negative real zeros a polynomial might have. Now, I'm going to start with this cubic polynomial as the first example. And so let's remember that because this has a degree of 3, that means we should be expecting 3 zeros or 3 roots for this polynomial. Now, the rule of signs tells me that the number of positive real zeros is going to be equal to the number of sign changes in f of x, or it's going to be less than this number by an even integer. So it sounds a little confusing, but let's look and see what it looks like in practice. We're going to start out by looking for the number of sign changes in f of x. My first term is a positive term, and then my second term is negative. And so right there I have one sign change. My third term is still negative, and my final term is also negative. And so for this particular polynomial, I only have one sign change. And according to the rule of signs, that's going to imply that we have one positive real zero. Now the rule says that the number of real zeros equals the number of sign changes or is less than this number by an even integer. So if I subtract an even integer, then that could also possibly be the number of positive real zeros. Well, in this case, the smallest even integer I can subtract is 2, and if I subtract 2 from 1, I end up with a negative number. And so in this case, the number of sign changes does equal the number of positive real zeros. Let's look at the second part of the rule. It tells us that the number of negative real zeros of f of x equals the number of sign changes in f of negative x, or is less than this number by an even integer. So to try this part of the rule, we're going to plug in negative x. So I get 2 times negative x cubed minus 3 times negative x squared minus 18 times negative x minus 8. And let's do some simplifying here. If I cube negative x, then it stays negative. And so I end up with a first term here of negative 2x cubed. If I square negative x, it turns into a positive, and then times negative 3. So that's just going to stay negative 3x squared. Then I have negative 18 times negative x, which would become plus 18x. And then finally minus 8. So I've plugged in negative x. Now let's count the sign changes. My first term is negative, and my second term is negative, so no sign change. But my third term is positive. So notice right here I've changed from negative to positive. And then my last term is back to negative again, and there's another sign change. So in this case, I've got 2 sign changes, which would imply 2 negative real zeros. Or the number of zeros could be less than this number by an even integer. Well, this time, if I subtract 2 from 2, I get 0. And so that's also a possibility. That means that I could have 2 negative real zeros, or I could have no negative real zeros. So in summary, for this particular polynomial, we found out in the first half that it has one positive real zero. And then here we see that there are 2 negative real zeros, or there's 0 negative real zeros, which means we definitely have one positive root, and then we either have 2 negative roots, or we have no negative real roots, which would mean we would have 2 imaginary roots. Let's look at one more example. Here we have a polynomial with a power of 5. First thing we're going to do is count the sign changes for g of x. We start out with a positive term. My second term is positive, so no sign change. My third term is positive, so no sign change. But my fourth term is negative. So here I have a sign change from positive to negative. And then my next term is negative, and my last term is negative. So we have one sign change, which means it looks like we are going to have one positive real zero. All right, now let's find g of negative x. So that's going to be negative x to the fifth plus 9 times negative x to the fourth plus 16 negative x cubed minus 60 times negative x squared minus 224 times negative x minus 192. Okay, let's go back and simplify. If I raise negative x to the fifth power, it's going to stay negative, so negative x to the fifth. Negative x to the fourth turns into a positive, so I still have plus 9x to the fourth. Negative x cubed stays negative, and so the plus 16 is going to turn into minus 16x cubed. Negative x squared is positive, so this is going to stay minus 60x squared. Negative 224 times negative x becomes plus 224x, and then finally minus 192. So now let's count our sign changes. Our first term is negative and the second term is positive, so there's a sign change. Then my next term is negative, so I've got another sign change there. The next term is negative, so we're still the same. But the next term is positive, so here I've got a sign change from negative to positive. And then my last term is negative, so another sign change there. So this time we've ended up with 4 sign changes. So that would imply that we might have 4 negative real zeros, or we might just have 2 negative real zeros, or we might have no negative real zeros at all. So, according to Descartes' rule of signs, definitely we have 1 positive real zero for this degree of 5 polynomial. But the negative real zeros, there might be 4 of them, there might be 2 of them, or there might be none of them. But there's no possibility that there's only 1 negative real zero or only 3 negative real zeros. It would have to be 4 or 2 or 0.